Good morning. Hello, dear students. And we have seen one-dimensional motion in horizontal and vertical, and then we have seen some application in two-dimensional, and in that we have successfully completed introduction of projectile motion. And today we are going to see applications of projectile motion. And in the application of projectile motion, the first point is horizontal projectile motion. We are going to discuss in today's class what is horizontal projectile motion, and after completion of that concept, we are going to see some logical and critical questions in the horizontal projectile motion concept. Right? I hope you will enjoy my class today. And wherever or if you could not able to understand, let me know through the comment section. And if you want any extra efforts from my side, still you can message me or you can comment me in the comment box. I will definitely try to give you whatever your requirement for your success in future, right? Then first one is horizontal projectile motion. Horizontal projectile motion. Here, the first point is, suppose an object is present here. This object is falling here, let us assume falling here, and initially this object is having a velocity u, initial velocity, and this velocity vector is parallel to the horizontal or x-axis, the condition is here, initial velocity vector here parallel to x-axis, right? This is the first point we need to remember. And after that, here let us first of all try to write trajectory equation for horizontal projectile motion. Trajectory equation means representation of equation in terms of x and y coordinates. This is what we have already seen in the first topic of kinematics. And see here, let us assume the object might reach us this location from this point location, and let us assume the name of this point as x comma y, right? Now by using sx is equals to uxt plus half axt square. That means here I am going to find displacement of the object on the x-axis. So this value will be equals to x. And as I told you already, from where if object starts its journey, that location we are considering as origin. So this will be acts as origin, and object's displacement on x-axis only be required. That's why substituting sx place means x only, and with respect to origin, the point x is lying right side. So I am taking it as positive, and u is parallel to the x-axis. So its value remains u only. And note one important point is, if the velocity vector is parallel to the x-axis means it does not contains any y-axis value on y-axis value. So you can consider uy is equals to 0, ux is equals to u. Again I am repeating, as the initial velocity is parallel to the x-axis means it does not have any velocity on the y-axis. So we can consider initial velocity on y-axis as 0, right? But for this formula we need only initial velocity on x-axis. Ux means u only into time taken, let us assume t. And as I told you, until and unless they represent some acceleration is lying or present on the x-axis, we can consider acceleration on x-axis is 0. So next point is x is equals to ut and t is equals to x by u. Let us see this as equation number 1. Let us assume this as equation number 1. Then next point is, again I need to find y value, and this is original line of motion and object is at this point, and we can consider this displacement as y. The displacement on y axis is y. Now here by using Sy is equals to u by t plus half a by t square, a by t square. Sy, that means, see, from origin point, this point is lying in the downward direction, so we have to keep it as minus y. Minus y is equals to uy, as I discussed just now. As the object is initially parallel to the x-axis, it does not possess any initial velocity on the y-axis, so we can keep it as 0 into t plus ay, acceleration due to gravity is only existing. This is equals to minus g into t square. So y is equals to half gt square. Y is equals to half gt square. Let us assume this as equation number 2. Let us assume this as equation number 2. Now here we can substitute equation 1 in equation 2. Substitute equation 1 in equation 2. Then y is equals to half g, x value is equals to sorry, t value is equals to x by u whole square. So y is equals to half g u square x square, and this is representation of trajectory equation of the horizontal projectile motion, and this equation is containing both y value as well as x values. I hope it is very clear from my side. And the next point is, let us find displacement of the object. Displacement of the object after time t. After time t. Displacement means, here roughness I can try again. Right. We consider this length as x, this length as y, and this is the displacement. Displacement, right? The line representing here is the displacement line. Now how can I find that displacement? Displacement means, can I say it is representing with the position vector r, then r is equals to xi, and you have to remember one point here. Most important point is, x is lying to the right side of the origin from where it starts its journey, origin. So we can consider it as xi, and y is lying downwards with respect to the origin point, minus yj. Clear? And we have seen x is equals to ut and y is equals to half gt square. These two terms I had already represented here. X value and y values. So you can get the help from this x value and y value. Right, x is equals to ut and y is equals to half gt square, and I am directly substituting these two here. So the displacement vector is equals to uti minus half gt square j. Uti minus half gt square. And the next point is, see here, if I want magnitude, I can say under root of ut square plus half gt square whole square. This is the magnitude of the displacement. And next point is, what is the angle made by displacement vector with respect to x-axis? Then angle made by made by displacement with the x-axis with the x-axis. See here, tan phi, let us assume tan phi is equals to we can consider its velocity, sorry, we can consider its parallel vector at this point by tan phi is equals to y, and this is x length, obviously this is x means this is also equals to x, so y by x, which is equals to half gt square by ut, and t will get cancelled. Then phi is equals to tan inverse of gt by 2u. gt by 2u. This is tan phi. And the next point, see here, finding instantaneous velocity. Finding instantaneous velocity. How can I find velocity? Instantaneous velocity means, see here, object is parallel, and at this point if I am going to find velocity, right, and we know, right, this is velocity v, and this will be vx, this will be vy, and let us assume this is making an angle alpha here, and instantaneous velocity on x-axis by using vx is equals to ux plus axt. Now, here Vx, final velocity at the point Vx is equals to Ux. Initially, this is parallel to x-axis, right? U plus 0 into t. That means Vx is equals to U. First point. Now, similarly, Vy is equals to uy plus ayt, then uy is equals to 0, because as the object is parallel to the x-axis, it does not contain any component on the y-axis. So plus minus gt, and vy is equals to, see here, this is representing in the downward direction, means we have to keep it as negative, because it is representing in the downward direction. As I told you, from origin point, whichever is representing in the downward direction on the y-axis, we have to consider it as negative, and vx is of course downwards with respect to origin, but it is representing in the rightward direction. That's why we are considering it as positive. Then this will be minus gt, and vy is equals to gt. Now, velocity vector is equals to vxi plus vyj, that is final velocity on x-axis plus final velocity on y-axis. That's it. Now, here vyj, which is equals to ui minus gtj, and next point, if I want its magnitude, I can write it as u square plus g square t square. And third point, if I want what is the angle made by velocity vector at that particular point with respect to x-axis or with respect to horizontal, I can find that by tan alpha is equal to vy by vx, and vy value is gt and vx value is u, then alpha is equal to tan inverse of gt by u. This is the instantaneous velocity attained by the object in the horizontal projectile motion, right? Very good. Then next one is range, finding time of flight time of flight time of flight. Suppose we know the value of y. Suppose we know the value of y, right? How can I find time taken by the object to move from here to here? And here, let y value is given is given. Now, by using Sy is equals to uy t plus half ay t square, right? Sy means displacement on the y-axis minus y is equals to uy. Initial velocity on y-axis is equals to 0 because initially it is parallel to x-axis. Parallel to x-axis, right? So 0 t plus half minus g t square, and according to the condition we know the value of y, so we can write 2y by g under root is the time of flight, is the time of flight, right? And right, 2y by g, 2y by g, right? Next point, how much will be the range? Range means the displacement traveled by the object, sorry, right, the displacement traveled by the object on the x-axis, right? So finding range, finding range, how can I find range? By using Sx is equals to uxt plus half ax t square, and here acceleration on x-axis is not represented in the question, so we can consider it as 0. Then range is equals to ux, that is initial velocity on x-axis, and time is equals to 2y by g, and half ax is equals to 0. That's why we can conclude this is the range. We can conclude it as the range, and this is what is the concept of horizontal projectile motion, right? I hope you understood very clearly, and if you still have any doubts or any assistance from my side, you can message me in comment box. You can comment me, I will definitely try to give you the reply, right? And based on this concept, let us see some numericals which are really logical, important, conceptual and critical also, right? Now the first question is the first question is, a rubber ball escapes from the horizontal roof with a velocity, that is, this is a rubber ball, it escapes from the point with a velocity of v is equal to 5 meter per second. The roof is situated at a height 20 meters, that is, this is equals to 20 meters. If the length of each car is equals to 4 meters, that means let us assume these are the cars: first car, second car, third car, fourth car, fifth car, sixth car, and each length is equals to 4 meters, like this. Each length is equals to 4 meters. With which car will the ball hit? That means it will fall like this, and on which ball, sorry, on which car the ball will fall. This is what the question. We need to find whether the ball will fall on first car or second car or third car or fourth car, that one. And here the question, if you could understand, based on the concept, they are asking us to find the range value, but instead of directly giving us as a conceptual question, directly giving us find the range value, they are making us to think, confuse us. And here we are very strong in the concept, right? Now we need to find the range value that will automatically tells on which car the object will, fall. Clear? Let us find the range. And before finding range is equals to, we know u into t, and here half 0 t square. Since the acceleration on x-axis is not represented in that question inherently, so we are considering ax is equals to 0. Then range value is equals to ut only, but here u value is given as 5 meter per second, 5 meter per second, but there is no time representation in the question. So for that purpose, we need to find time value and substitute in the equation 1. Finding time of flight, time of flight, right? By using Sy is equals to u by t plus half a by t square, right? Then Sy means obviously the object is falling on the ground, means the total displacement traveled by the object on y-axis remains 20 meters only. So Sy minus 20 uy, they represented in the question itself that the object is parallel to the x-axis. So horizontal roof, right? Then inherently the representing parallel to the x-axis means initial velocity on y-axis becomes 0. Then this will be 0 t plus half minus g t square. So 20 is equals to half 10 t square 5 4. So t square is equals to 4. That means time taken to reach the object from top of the tower to car is equals to 2 seconds. Now here the range value is equals to initial velocity is representing as 5 and the time taken is 2, which is equals to 20 meters. And here this is 4 meters, this is 4 meters, 8 meters, and we need to 10 meters only. That means object will fall like this, object will fall like this at a 10 meters distance from the origin. So answer becomes, therefore the ball will fall on third car. Third car. This is what logically they want answer from our side, right? And the next point we will see next question. Question number 2. In the question number 2, see here, with what velocity v naught should a ball be projected horizontally from the top of the tower, from the top of the tower, right? With what velocity v naught should a ball be projected horizontally from the top of the tower so that the horizontal distance on the ground is theta h? Suppose they are giving ball starts its journey from here and it is falling at this location, and this is equals to neta h. They are representing this as neta h, and this is equals to h. This is equals to h, and where h is the height of the tower. Very good, right? And they are asking us what is velocity v naught. What is velocity v naught, right? Now first of all, as per the concept, the range is given, range is given neta h, neta h, and by using Sx is equals to uxt plus half ax t square, and range is equals to neta h, and v naught ux is the initial velocity on the x-axis, which is the given as v naught into time. Half acceleration is not given in the question, so we can consider it as 0. So neta h is equals to v naught t, v naught t. Now time is equal to neta h by v naught. Let it be equation number 1. Let it be equation number 1. Now by using Sy is equals to u by t plus half a by t square. Otherwise you can remove this one and keep it as equation number 1. Then Sy, the displacement of the object on y-axis is capital H. So object is obviously falling in the downward direction from the origin. So we can consider it as minus h, and uy is equals to initial velocity on y-axis is 0 plus ay acceleration due to gravity t square. Now h is equals to half gt square. Then t is equals to 2h by g under root. Let it be equation number 2. Substitute equation 2 in 1, right? That means neta h is equals to v naught under root of 2h by g. Now, ultimately, beta naught is equals to under root of g by 2h into neta h. This is the initial velocity they are asking us to find. And second part of the question is also determine the speed of the ball when it reaches the ground. They are asking us to find speed of the ball when it reaches the ground. That means it is falling at this point, and what would be the velocity in this case? Now this velocity is having two components. One is Vx, one is Vy, and let us assume it is making an angle alpha, right? And initially it is parallel, so we can consider it as V naught parallel to ground, right? Now by using by using Vx is equals to Ux plus Ax t square, and Vx final velocity on the x-axis, this is the final velocity on the y-axis. So Vx is equals to V naught plus 0 t. Obviously they are not mentioning any acceleration on x-axis, so we are keeping it as 0. So Vx is equals to V naught, let it be equation 3, and Vy is equals to, similarly Vy is equals to Uy plus Ay t, and Uy initial velocity on the y-axis, how much it will be? It would be 0 because the object is parallel to the x-axis initially, so 0. And according to our understanding, acceleration of y-axis is remains g, because Earth always tries to pull every object towards its center. Then this will be Vy, and Vy is equals to minus gt, and here Vy should be equals to negative, because should be represented in negative because it is in downward direction with respect to the origin point in the y-axis, right? Then Vy is equals to gt, and time of flight is equals to, we have seen, under root of 2h by g. Time of flight is under root of 2h by g. So here Vy is equals to g under root of 2h by g, right? Otherwise you can also write it as under root of 2h g square by g. G will get cancelled. Vy is equals to under root of 2h g 2gh. Vy is equals to under root of 2gh. Now, and they are asked the velocity vector here is equal to vxi minus vyj, because Vy is representing in the downward direction with respect to origin on the y-axis, right? And ux, this is v naught I minus under root of 2gh. And see the question very carefully. They are not asking what is the velocity vector value or the direction made by the velocity vector with respect to the horizontal. They are not asking these two questions, and these two questions we were covered in the concept inherently. But they are asking us to find the speed value. What is the speed value? Speed is the magnitude of velocity. Can I say like this? So obviously the speed value is equal to magnitude of velocity, means under root of v naught square plus 2gh whole square under root of. So we can write ultimately speed is equal to under root of v naught square plus 2gh. This is what is the speed value, right? And next and third question is, see here, the third question, again a logical question. Here a relief food package is dropped from an airplane which is moving horizontally with a velocity of 30 meter per second. Let us assume it is a airplane. Let us assume it is a airplane. I am not perfect artist, that's why I can draw like this. right? And the food package is dropped from the airplane, which is moving horizontally with a velocity of 30 meter per second, 30 meter per second, at a height 50 meters, at a height 50 meters, at a height 50 meters. Find the time of flight of the package. See here, suppose food package is present here, and the food package is throwing out from the flight like this, like this, suppose. And when that person is dropping or throwing out, the velocity of the food package is similar to the velocity of the airplane. Can I say like this? Because food package is inside the airplane present initially. That's why the velocity of the airplane is equal to the velocity of the food package, and the direction of the airplane is horizontal, moving horizontal. So the food package will also moves with the same velocity horizontal to the x-axis, horizontal to x-axis, horizontal to x-axis. Okay, horizontal to x-axis, right? X-axis. Now, time of flight of the package. The time taken from here to here by using Sy is equals to u by t half a by t square, half a by t square. Then Sy is equals to minus 50, because object is falling here, means obviously its displacement on y-axis becomes the height of the airplane from the ground, right? Which is equals to 50, and with this we will consider as origin, and it is the final location. Final location with respect to origin, the final location is in the downward direction. So the downward direction point we consider as negative, negative, and here displacement on y-axis only required for us. That's why I take it as minus. Then uy, initially the object is moving with the same velocity of the airplane means, and that airplane is moving horizontal means, the initial velocity on y-axis for the food package remains 0. So 0 t plus half minus g t square, right? And 50 is equals to half 10 t square. These two will get cancelled. Then t is equals to under root of 10 seconds. This is what is the time of flight. Time of flight, right? Then second part of the question, b bit, location of the point of striking of the food package. That means indirectly they are asking what is range value. Indirectly they are asking what is range value. So the range value, finding range by using Sx is equals to uxt plus half axt square. Then range is equals to ux, initial velocity of the food package on the x-axis is 30 into time is root 10 plus half 0, because the airplane is not having any acceleration according to the question, right? Then the range value, the place where the food package will fall on the ground is 30 root 10 meters, 30 root 10 meters. And third one, velocity of the package at the time of striking the ground. They are asking us at what velocity the object is striking the ground. So can I say here, this is velocity, this will be vx, this will be vy. Again, we by using, see, you can understand one point here. Whatever we were covered in the concept, the question is revolving around the concept only. But the most important point is, logically they are asking, instead of directly find these values, they are asking us to find in the same values in indirect way. They are asking in indirect way, and we need to analyze the situation, and analyzation and absorption and quickly response to the concept, sorry, given question relates to the concept. That is most important in solving our entrance examination. Clear? Now by using vx is equals to ux plus ax t and ux is the initial velocity of the foot package. Just I had discussed so many times, so I can skip. And acceleration 0. This one is also we have discussed so many times. This is 30 meter per second. So this is what is velocity of foot package on the ground before it reaches the ground on the x-axis. Simultaneously vy uy plus ay t, then uy is equals to initial velocity on y-axis. Again, same concept. Foot package is having velocity on x-axis only because it is having horizontally moving airplane. It is in the horizontally moving airplane. That's why uy is equals to 0 and ay minus g time is t. That time value we have found here as root 2 root 10. So minus v by minus 10 root 10. So velocity on y-axis is 10 root 10 meter per second. And here velocity of the package at the time of striking the ground. So v is equals to vxi minus v by j. I hope you were very strongly understood how I am representing, why I am representing minus v by here, and this becomes 30 I minus 10 root 10 j, and this is what is velocity. And this velocity we are representing in vector form, and they are not asking us what is speed. If they are asking us to find speed, then as per the previous question you can find its magnitude as 30 square 10 root 10 whole square. This is the speed value. Clear? And fourth part of the question is finding displacement. And here displacement means, see, this is foot package falling here at a height of 50 meters, and initially it is having 30 meter per second. Displacement is the separation from initial point to the final point, right? Now it is the initial point origin and it is the final point. Now if I draw a straight line like this, and this gives displacement, right? Now we are going to find this displacement with position vector like r xi minus yj, because it is representing in the downward direction of the origin, from the origin. So this will be minus y, from origin downward direction minus y. That's why I'm considering like this. And from origin this distance is on x-axis positive only. That's why I consider it as positive. And that x value we found as range. That range value is equals to, we found that range as 30 root 10 I minus y is the given 50j. This is what is the displacement. Vector. And if they are asking its magnitude, this will be under root of 30 root 10 square plus 50 square, right? Which is equals to under root of 900 into 10 plus 2500, which is equals to 11,500 meters. 11,500 meters. I hope you enjoyed today's class. That's the end of the topic. And if you still need any assistance from my side, I am requesting you can message me. You can let me know your requirement through the comment box. And for daily practice sheets and weekend examination papers, from today onwards I am going to definitely give these worksheets. And these many days Telegram channel has been blocked in India. That's why I didn't send you those questions. But from today onwards, I would try my able best to forward those worksheets and examination papers on weekends and worksheets on daily basis. And my motto is make you to be more strong in the subject. And ultimately, all of you have a bright future. Have a great day. Take care. Bye bye.